Hi, and welcome to another episode of the TeachMeCoco.com video tutorials. In this episode, we will be discussing the C programming language. Now, C is a programming language that is a low-level programming language. That means it has low-level access to the system, and it is the foundation of the Objective-C language. And this is important because the Objective-C language is used as the primary language for iPhone and Mac development, specifically of graphical applications. This episode is designed specifically for users who already have some understanding and experience with a programming language in general. So to start out with, what we're going to do is create a new project in Xcode. We can do this by going to the File menu, clicking New Project. On the left here, make sure Command Line Utility is selected and select Standard Tool. This will allow us to build a command line tool that uses the C language. So let's do this, name it something pretty basic, and put it wherever you'd like. Now once we have this project, you can open the console with Shift-Command-R. And I'm going to resize it just a little bit. And now what we're going to do in this project is first open the source section, and then notice we have main.c. This allows us to enter our C code right in a function that's already provided for us called main. Now we'll discuss functions a little bit later and what their purpose is, but for now all you need to know is that main is a special function that is where program's execution begins in the C language. So what we're going to do first is run this project with Command R, and you will see over in the console to the right that Hello World is what is displayed. Now the reason that Hello World is displayed is because we have it inside the printf function, and then it has a new line afterwards inside of the quotes, which makes it go down to the next line. Now we can also pass arguments to the printf function, and we'll see this by creating a simple variable. And the variable will be called I for now, and we'll set its value to 42. And the way that we print it is using the %d, and then we put it afterwards as an argument to the printf function. And when we print it, we will see that it is printed right before the new line. And there it is. So this shows you a little bit about how to do basic debugging in the C language and how to print out variables that are of this one specific type. Now let's discuss variables a little bit more in depth. Now in the C programming language, there are 4 basic types of variables which all of the variables are derived from. The first one is an int, which is a whole integer. It does not have any decimal point. The second one is a float, which does have a decimal point. The third one is a double, which is a more precise float. And the fourth one is a char, which is a single character. Now technically, a char is actually a numeric value, but we'll discuss a little bit more about strings in C later. Now to demonstrate how to use variables and print them out with a little bit more flexibility, we'll create 3 new variables. F will be a simple decimal. Double will be a more precise decimal. Now the numbers that I'm using here aren't actually the limits, they're just used as an example. And C will be a char, which has single quotes. This is a special type of variable. So when we want to print them out, we will use the printf function just like we did before, except we will change this a little bit. What you see here is the %d is used to print an integer, %f is used to print floats and doubles, and the %c is used to print out the characters. So when we build and go using Command R, we see that in our console over here, the values that we put in here are printed out just like we had set them. Now this serves to demonstrate how you create a variable, how you set its value, and how you access its value. Unlike in many other languages, a variable in C must be explicitly declared before it can be used. And the way you access it is just by typing its name, instead of using a symbol such as the $sign. Now another way to declare a variable is by putting a comma in the same declarative statement. And when we do this, when int is the first keyword in the line, then all other variables that we create will be of that type. So we could create any other amount of variables inside this line that would all be ints. Now that we've seen how to create a variable and print it out into the console, let's take a look at a special variable called an array. Now, an array is a collection of variables that all have the same type, and they are identified by a name and by the bracket symbols to access their elements. The way that you access the elements of an array is using an index, and the indexes start with 0. And one more thing about arrays in C is that it has a fixed size. Once you have set the array with a certain size, you cannot change that array. You can simply copy the array with a different size and then copy the values into it. So those are the basics of the C array. Now let's take a look at the C arrays in action. As you can see, I've altered the project a little bit to already include an array. And what you see here is the int keyword, which signifies that the array will be of all integer values. And then you'll see the brackets right after the name of the array, and that is how you declare that a variable is an array and not just a regular variable. And the number inside, as you would probably guess, is the size. And the way that we access them is the same way that we set them, by using the array's name and then the bracket symbol afterwards. And what this does is this says that we're looking at the array and we're looking at the element at the index 0, which is the first index. And this is going to set the first element to 65, the second to 66, and the third to 67. Now when we print this out into the console by using Command R, we're going to see that the numbers 65, 66, and 67 are in fact printed out. And this is because the integer is being sent to the %d, and instead of the entire array, this allows us to access a single element. So that is the basics of using a C array. There's a few things that you should know about the C array. One is that if you try to access an element that is not inside the bounds, for example, if we were to try to access 3, which is actually the fourth element in an array with a size of 3, then the behavior is undefined. If you try to set it or if you try to access it, you're accessing memory that has not specifically been set to be used by this array. So it could print out garbage or it could result in a crash. We really don't know. So let's take a look and print it out. And in this example, it printed out 0. It's just happenstance, but if we change it to something a little bigger, we'll see that we got a seg fault. So that is the dangers of not staying inside the array's bounds. And that is why in C, it's very important to keep track of the size of an array and to access only the elements inside. The next thing that we're going to take a look at now that we've discussed arrays is strings. And strings are really just a special type of array. They're an array of char types. They can be created for our convenience with the double quote marks. And one more interesting thing about these strings in C is that they have an invisible character at the end that has the value of 0. So now let's take a look at strings in practice. First, let's change this back to 0 so that it accesses the first element. And now, instead of this being an array of integer values, let's change it to char and see what happens when we print it out. As we can see, numeric values are still printed out just like before when this was an integer array. The reason for this is because that the char type is really just a special type of number. And when we go over here and we change this %d to %c, we'll see something interesting happen. We'll see that ABC is printed out into the console instead of 65, 66, and 67. This is because those numbers are the values, are the numeric values of ABC in the ASCII character set. So what we're going to do right now is change the char back to an int and see what happens when we print this. And we see that ABC is once again printed out in the console. The reason for this is because those types, although they don't have the same size, are both numeric values that don't have a decimal point, and so %c expects a numeric type. Now that we've discussed that strings are really just a bunch of numeric values, let's take a look at how to set them in a more human-readable way. Instead of using 65, we're going to change this to A that's enclosed in single quotes. And what this does is this tells the compiler and the runtime that it's going to change this into 65 for us automatically, but we don't really need to know what value it is. So in order to do this, let's build and run and see that A is printed out just the same as before. Now we can do this with all of these, or we can use something else that the compiler of the C language gives us, which is double quotes. Now what we're going to do is change this value first to 4. This means that the array is going to have a size of 4. And like we discussed earlier, this is important because a string in C needs to have an extra character at the end that contains the value 0. And the double quotes are going to create that for us, so we don't need to put that in there. So let's just type ABC into here. We'll delete these lines where we manually set the array. And then one more thing that we should notice is that we're changing %C to be %S. And we're going to get rid of the brackets there, which indicate a specific element, and we're just going to pass the entire array to the function. Now when we do this, we will see that there is an error. This is because we cannot set the double quotes to a an integer array. We need to set it to a character array. So let's change that to a character. And now when we build and go, we will see that ABC is printed out on a single line, and then it stops there. So let's take a minute to look at the string in the C language a little bit more in depth. Now the reason that there's a null terminator is because in C, it's just an array of characters, and that's all a string really is. And because of this, it doesn't really have any information about the string's length. We know because we can see that this is 3 characters, but there is no other way for the compiler or the runtime to know that this is only going to be 3 characters. So what it does is it adds a kind of a stop sign at the end of the string, and that is the character 0. Now, what we could do instead of setting this using the double quotes is we could set that ourselves. And what we'll do is we'll use the bracket accessor once again, and we will set all 3 elements of the array, and then the third one, the fourth one will actually be a 0. Now when we print out the array, the same thing is going to happen. As we see in the console, ABC is once again printed. If we were to omit this line and then make the array only have size of 3, then anything could be printed afterwards, including garbage. And this is because if there's not a 0 there, then the printf function does not know where the string ends and will continue going. Now chances are, as we can see here, it's probably going to have a 0 right now. But that's just happenstance. Really, the behavior is undefined. Now pointers are really the foundation of C and what makes it so powerful. A pointer is a direct pointer to some memory in C that is used by the operating system. Now using the example that we just made using strings, let's take a look at this chart that we see below. The first part of the chart that's the top has hexadecimal numbers which are used as addresses. If you're not too familiar with hexadecimal, that's okay. For now, we'll just notice that a value, for example, of 0x9 is what we know as 9, and 0xa is what we know as 10. And so the decimal numbers 1 through 16 are correlated with the hexadecimal numbers 1 through F. So in this example, we see that 65 is the value at the memory address 8, and 66 is at 9, and 67 is at 10, and at 11 is 0. This is our 4-element array or string that we created earlier. Now that we've taken a look at where the pointer points to and the relationship between a variable, a pointer, and memory in the operating system, let's take a look at a pointer in practice. Now let's go back here, change the size of this character array to 4, put ABC back in. Remember that the extra element at the end of the array is used as a null terminator. We'll get rid of these and then we'll print out the array again. And as we see in the console, ABC is once again printed. Now what happens when we use this? This is the asterisk, which is used to symbolize that the character is now a character pointer. So array is a variable that is a character pointer. And pointers and arrays are pretty interrelated in C. They're not exactly the same thing, but they have a lot of the same qualities. So let's take a look and run this and see what happens. And there it is, ABC is once again printed out. And this is because array that's being passed into the printf function is actually a pointer, and we can see this by using %p, which will print out the address of the pointer variable that we're passing in. And when we do this, and when we run Command R, we'll see that it prints out some hexadecimal address. The address itself isn't very important unless you're comparing it to another address in terms of size or distance. What is important is the fact that array and what we're actually passing in is a location to the start of the string. So once the printf function knows where the string starts, it knows how to keep going forward in the array, iterating over every single character until it hits that stop sign or the null terminator as we discussed earlier. So now we've seen how strings, arrays, and pointers are really very interrelated with one another. But really, that's not the only way that we can use pointers in C. Actually, pointers are much more powerful than just being used for strings. So let's take a look at creating an integer pointer called I. And instead of setting its value to 42, we're not going to set its value just yet, because setting its value sets not what the value contains of the variable, but where it's going to point at, what address in memory. So saying 42 would really be the same as saying the contents of I will live at the memory address 42. And since we don't know what lives at 42 right now, we're not going to put in a constant number. Instead, we're going to use a special function called malloc, or malloc. And this function will actually create memory for us to use. It doesn't really create the memory, it allocates the memory for us, and then says you can use this sized memory in this chunk at this address space. And what it returns is the address space that I is going to point to. And we're going to use another keyword inside of it to specify the size of the array called sizeOf. And we're going to specify that the variable. It will be the size of a single integer variable. And that's all we really want right now since we're not creating an array. Now, in order for the malloc function to be recognized, we're going to need to include something called stdlib.h. And once we do that, we'll see that the malloc function is once again recognized. So once we do this, let's print out the address space, just like before, and run, and there's the address space. Now we can't print out the value just yet because we haven't set it. And because we haven't set it, the one tricky thing about C is that if you have not set a variable's value, it's undefined. It literally takes up the memory of whatever was there before it and uses that value until you explicitly decide to set it to something else. Now let's discuss a little bit about how you access an array's contents. Instead of saying this is where we want to look at about what's being pointed to, we use the asterisk symbol to say this is the contents of the array. So this whole thing right here will be evaluated. Now, because it's an int variable, we're going to use %d, which will print out its value. And when we do this, we're going to get garbage. Just happens to be 0 this time. So let's use the same asterisk symbol to set the value. And when we do this, we will see that 42 is being printed out because that is what lies in I. Now, we're not going to discuss memory management too much in this episode, but we are going to discuss it for the sake of good practice. When you create your own memory, you're going to need to free it when you're done using it, and we use the free keyword to do this. It's actually not a keyword, it's a function in the standard library. And the reason for this is because the compiler and the runtime don't really know when you're done because there's no garbage collection, so it doesn't know when you're done using the variable. So we need to manually free it ourselves. So the result will be the same as we see when we build and go, but instead this time we have proper memory management. So that's not too important, but it is good practice, so try to use free whenever you use malloc. Now, just a minute ago I hinted on the fact that you can use the pointer to an integer value, or a pointer to any kind of type, to create an array dynamically using the malloc function instead of just a single variable. We will take a look at this by using the multiplication symbol. And this is literally going to create an array that has the size of an integer times 3. So really that's saying we're going to be creating 3 integers. And the way that we can set them is by using the parentheses and the plus sign. This, as it stands, is really just I plus 0, because we're taking a look at the address of I and adding nothing to it, and then we're taking the value of that and setting it to 42. Now if we want to access the next element, what we do is we do plus 1 and plus 2, just like you saw before. So we can change this to 1, 2, and 3, and then we can print them out in exactly the same way. So let's do that and see the manual way of creating an array. And let's build and go, and you can see that 1, 2, and 3 are printed out into the console just like we have set them up here. So we're almost done with the section of variables, which is part 1 right now. We're almost done. We have one more thing to cover, and that is the struct. Now a struct in C is literally just a structure. It contains and holds up other variables. It could even be called a supervariable, in fact. Basically, its variables that are inside of it are called fields or members sometimes, and you can access them with the period symbol. And we're going to take a look at a concrete example of structs right now. Now what you see here is a struct which is declared outside of the main function. Now this is usually where structs are declared so that way you can use them in multiple functions. In this case we have the keyword struct, which indicates that this is beginning a struct, the name of the struct, which is dog in this case, followed by curly braces. And this is important, but oftentimes people who are just starting out with C will forget, is the semicolon after the end of the struct's definition. Now inside of the struct you can name any variables of most any type, and we have a character array called a name, which is really just a string, and the integer, which is age. And we're going to set them, well first we're going to create the variable called sumDog using the struct dog. Now this is an entire type by itself, and so when we build and go, we're going to notice that sumDog.name is printed out as a string, which is %s, and sumDog.age is printed out as an integer. And we did not set the age, but we did set the name. So let's take a look, and it just happens to be garbage that's printed out by the age. So let's set the dog age equals 23, I guess he's an old dog, and when we print it we see that both values are printed out exactly like we specified. Now struct dog is kind of an archaic, obsolete way of specifying that the dog type is a struct. We don't really need it. So we're going to very briefly discuss something called typedef. We're not going to discuss it too much because it doesn't really fit along into the context of this tutorial, but what you can do is type the word typedef before struct, put an underscore before the name dog, and right before the semicolon, put dog. And now we can remove struct and just use dog. And this makes it also easier for Xcode to do more of its own type checking and to do syntax highlighting, for example. It also makes the refactor option a little bit easier for Xcode. We won't be discussing that in this episode either, though. Now that we've created the dog and we run and see that it works just the same, let's take a look at structs in the context of pointers. Now with pointers you can use the % and the parentheses to access a pointer. But what happens when we have a pointer of a struct? For example, dog. Well, let's take a look. We'll use malloc to create a single dog variable, and we'll free it later for good practice. And now we can't access the elements anymore using the dot. Instead, we have to dereference the pointer, which we can do with %*. And when we do this, it's going to allow it saying that this whole expression right here is essentially a dog. It's not a pointer to a dog. So it's just a dog, and that's why the period works. But down here, it's saying that we can't do it because it's not a structure. It's a pointer to a structure. So what we're going to do is use a different symbol that we haven't discussed yet. I'm not sure what it's called, but it's basically a hyphen and a greater than sign, so I call it the arrow because that's what it looks like to me. So when we use this and we build it, we'll see that the compiler doesn't complain anymore. And that's how you access the fields of a pointer to a structure. And now when we build and go, we see Fred and 23 printed out into the console once again. Now these are basically doing the same thing. They're both accessing the fields, and they're just different ways. Really, it's up to you how you do it. Most programmers prefer to use the arrow symbol, and it just seems easier. So that is the basics of using a struct and using a pointer to a struct. So now we've finally discussed finishing all of the variables and types of variables that you can use in the C language. The next part, part 2, is about program flow. We will be discussing conditional statements such as if and loops such as while and for. Now chances are you've seen these kind of constructs in other programming languages, so we won't go into as much detail about these as we did about the variables. Now the first thing that we'll discuss here is the if, else, and else if statements. Basically, the if and the else if have parentheses after them, which has a condition inside, and the condition is evaluated. If it is 0, then anything afterwards inside of the block that's denoted with the curly braces will be skipped. And if it is anything other than 0, it will not be skipped, it will be run. So 1, 2, 3, and a million all equate to true in this instance. So now let's take a look at if and else in practice. When we run this program, you will notice that one of these statements is printed and not both. This is because the variable I is evaluated in this expression, and if it is true, then this will be printed. If it's false, then this. And because I is 0, that will evaluate to false, so we will have the word failure printed down there. Now, else is optional. You don't need it. And just like in most other programming languages, there's also an else if, which is basically a fancy way of doing nested ifs inside of the else statement. And we can specify any other condition inside of the parentheses, and when we run it, we will see that middle right here is printed instead of this one because 3 evaluates to true. Now you can have any number of else if statements, and they are also optional. And just like the else, you can emit both of these or one of these, and it will still compile just fine. Now another interesting thing here is these curly braces. We haven't really taken a look at them yet, but what they denote is a block of code. And the if and else statements either take a single line of code or a block of code. And a block of code allows you to have more than one line. For example, we have that. Now we'll see that when we run, both success 1 and success 2 are printed instead of just the first line. If we were to get rid of this block using the curly braces, then this is printed no matter what, whereas this is only printed if I evaluates to true. And when we run, we see that they're both printed, but what happens when we make I equal 0, so it will not evaluate it? Success 2 still prints no matter what. This is why the curly braces are important in this case. They allow you to run multiple lines of code. And we see that none of it prints now once we put the braces around it. Now we'll take a look at the while statement. While is very similar to if in the fact that it has a condition that is evaluated and then curly braces which denote the code to execute while the condition is true. Once all the code inside of these braces have been executed, then condition is evaluated again, and the loop jumps right back up to the top and continues to evaluate it. So let's take a look at a concrete example of using the while loop. In this example, we see that I equals 0. So when while evaluates I, it will never print the loop in the first place. So when we run, we will see that nothing happens. Now once we change I to anything that will evaluate as true, we see that the loop never really stops, and we have to manually kill the process to stop the loop. This is how while works. Now similar to while is the do while loop in C. Basically, we take the while and the parentheses, replace it with a do, go down to the bottom of the brackets, and then we will paste our while with the parentheses and put a semicolon after it. This is the basic syntax of the do while. Now the difference is that this kind of loop evaluates I after the loop has done going through its first iteration. So once we have I equals 3, it's really going to continue to print forever. But what happens when we change I to 0, where the expression would be evaluated to false? We will see that it will still print one time beforehand. Now the while statement can be useful for doing a loop that has a finite lifetime, where you have a variable and you want to stop when it hits a certain point. And we'll take a look at making I run 6 times, and the way that we'll do this is by doing I minus minus. That's essentially the same as doing I equals I minus 1. So when we run, we will see that this prints only 6 times, because once I equals 0, the loop will not continue. Now we can introduce something that is useful for these kind of control statements. There are 2 keywords. One is called break and one is called continue. And we will look at them, and first let's take a look at break. Break will actually break out of the loop completely, and it will stop doing any more of the code inside the loop, and then it will go directly to the end, which is right here. And we will see that this only prints one time because break will immediately exit the loop. Now continue is very similar in the fact that it does not run any more code inside the loop, but instead of jumping to the end, it jumps up back to the beginning. And we can take a look at continue by saying, well, first let's change printf to print out a number so we can notice what number we're at. It's going to print out the value of I, and when we run it normally, it will print from 6 down to 1. Now let's skip this code when I equals 3. We're going to use the double equal signs to indicate that the expression is not setting the value of I, but determining whether or not they're equal. So we're going to type the continue keyword, and when we do this, it will no longer print anything after 4, but as we see, the loop has never really stopped. This is because I minus minus never gets reached, so we need to manually kill the process. And in order to change this, we can put I minus minus above the continue statement. And when we do this, 5, 4, 2, 1, and 0 are printed, but not 3. And 6 also isn't printed, but that's because the printf function never sees I when its value is 6, because it's immediately decremented to 5. So now that we've taken a look at the do, while, and the while loops, let's take a look at another more complex type of loop. This often looks a little bit intimidating to people who are just starting out with C or just starting out with programming in general, because it has 3 sections inside of the parentheses. The first one is the initializer. It is used to set the values of the variables that will be used throughout the loop, and it's only called one time at the very beginning of the entire for statement. It's not called at the beginning of every iteration. The second section is the condition on which to continue. This is only evaluated after the loop is completed, each time the loop is completed. And the third section is what I call the increment, except it doesn't necessarily need to be used to increment a value. It really just updates the variables so that way the condition can be checked and possibly be different this time. So now let's take a look at a concrete example of the for loop in action. Now what you see here is the variable I is created as an integer first before the loop. This is necessary for older compilers and isn't really necessary today anymore, so we can remove this line now and we can put int I equals 0 right up there. Now the first section of the parentheses specifies that I will start out being 0. The second section says that the loop will continue as long as I is anything less than 3. Once it is equal to or greater than 3, the loop will not continue and go all the way to the end of the statement right here and continue at that point. The third section is incrementing I so that it keeps equaling one more number than itself. So let's take a look at this loop in action, and we see 0, 1, and 2. And this may be a little confusing at first that it's not 1, 2, and 3, but once again this is the one-off problem where in C variables often start with 0 instead of 1, unlike in certain other languages. So let's take a look at how we can use this in a different way. We can actually set I equals 3 and say as long as is greater than or equal to 0, we will do the loop and we will do I minus minus, which means I will equal 1 less than itself after every loop. So now when we take a look, we see that 3, 2, 1, and 0 are all run. This is actually 4 numbers, and that's once again because 3, 2, 1, and 0 are all meeting the condition I is greater than or equal to 0. If we only wanted to run it 3 times, we'd have to get rid of the equal. And there you have it. So this is the basic way that you use the for loop. Really, it's not as complex as it looks, and it's really pretty flexible. You don't have to have variables being evaluated the same way, or initialized, or even incremented or decremented the same way as you see here. You can do a lot more with for loops, and they're very useful for low-level C programming language. But this is the basic way that you're usually going to use a for loop. Now that concludes part 2 of this episode of TeachMeCoco.com's video tutorials, and that section was all about the control flow statements of a program, and this includes if, while, and for loops. Now we're going to discuss a little bit more complex control of the program's flow, and we'll do this by using functions. So let's take a look at the 2 functions that we have implemented in this file. The first one is called main, and we've been using this the whole time, and the second one is called greet. Now, the main function is different than greet in 2 ways. First, it has a different return type. This means that when the function's done executing, or when it hits a return keyword, then this is the type that is going to be returned. In this case, we are returning exit success. And if we hold command and we double-click exit success, we see where it is defined, and it is defined as 0. So this is really what we've seen the whole time throughout our tutorial, where we've had return 0. This means that the program has exited with success. The second part of this that is different are the argument lists, which are specified inside the parentheses. Now, the arguments to this function are actually the arguments to the entire program. We won't be discussing that in this tutorial, as it's out of the scope of the tutorial, but it's important to notice that the variables that are the arguments of a function specify the type and the name, just like you normally would declare a variable, but instead they're separated with a comma instead of a semicolon. Now, inside the main function, we are using the greet function. We are calling it. This means we're passing execution over to the greet function, which will happen up here. And when that happens, this code is run and this code is run. Now return is optional if it's at the end, because once control flow hits the end of the function at the last curly brace, then it is returned back to this line of code in the main function, and then it continues down the path. So let's build and run and see what happens. We see that down here, hello world is actually printed out. So this means that the greet function does not return any type. It is just a simple function to execute some kind of code on the inside of it that could optionally contain arguments. Now that we've taken a look at a basic function that doesn't return anything, let's take a look at a function that takes an argument and returns a value. This time it will return an integer. We'll change its name to double number, and we will move the printf function down here back into the main, and we will call this function now using the name of the function and the parentheses, and we will pass a number in as 42. Now, because there's nothing in the argument list up here already for this function, we'll need to put something in there. And let's do this by putting int and number. Now what we're going to return is a variable called n. Right now n doesn't equal anything, but we're going to set it to equaling number times 2. We don't need the parentheses, they're really just there for our readability of code. So when we run this program, we're going to see over here that 84 is actually printed out. And you can also, instead of passing the function as an argument to another function, you can set it as a variable. And let's create an int called a and set it to equaling double number 42. And we see the same thing printed out. We can also pass variables through functions, just like we do with the printf function, which is what we've been doing throughout this tutorial. That pretty much wraps up how functions are used and how they can add functionality to your program. Now what we're going to take a look at is casting. Now casting is pretty important sometimes in the C language because unfortunately not all types are created equal, and therefore certain types have different sizes than other types, and when you try to pass one to another, an implicit conversion isn't enough and you have to do an explicit conversion. We'll take a look at just the simple printf function for now, and we will pass a decimal number where a decimal number is expected. An integer number. And we'll use this with the %d. So we'll pass 42, and we'll see that 42 is printed out. But what happens when we pass it a float? Now in C, a float is specified with the period and then numbers afterwards, which are optional. 42 is not actually printed out, and the reason for this is because it's expecting a decimal number, whereas 42 is a different size. So what we need to do is cast. The way we do this is with parentheses with the type on the inside that we're casting to. And when we do this, we'll see 42 is once again printed out. So now that we're done taking a look at casting, let's take a look at scope. Scope is an interesting thing because it allows us to access variables outside of the scope and create variables inside of the scope that will be demolished when the scope is finished. Scope is essentially defined using curly braces, which is what we've been doing with functions and if and for statements, etc. all along. Now to create a scope, you can just simply use those curly brace symbols wherever you'd like. And this creates a scope where any variable on the inside of the scope will be no longer existent when the scope is done. So if we try to print I out here after it's been created inside of the scope and we build, we will find an error, and the error says that I is undeclared out here and that I is unused in here. So this is essentially the benefit of a scope, is that you can have variables with the same name inside the same function that have different values and that don't access the same memory. You can also access the memory outside of a scope, inside of a scope. For example, if we were to move I equals 42 out here and now change it to I equals 12, when we print it out, I will equal 12. This is because I has not been declared as a new variable inside the scope, so it's accessing this one. If we were to create a new one, we'd get a warning that I is unused, and when we print it out in the console to the right, we'll see that I equals 42 still. This is basically, in a nutshell, how you use scopes, and you can use them to your advantage. For example, using the same variable name without conflicting, or you can use them for good or evil. Really, it's up to you. Now this pretty much wraps up this episode of TeachMeCoco.com video tutorials. To recap what we learned today, we discussed the C programming language. Specifically, we discussed variables and their specific variables such as pointers, arrays, strings, and structs. We've discussed controlling the program's flow with if, for, and while loops, and we've discussed functions, their scope, and casting. If you've enjoyed this tutorial, please visit www.teachmecoco.com for other free video tutorials and other resources on getting started with iPhone or Mac development. You can also visit my own personal website at www.degutis.org, and it includes many tips and tricks on how to get started in Coco, how to think Coco, and it includes a lot of my open sourced software components that you can use in your own software. Thanks for watching and happy programming!